All right. So guys, last class we just introduced the concept of investment risk, which is basically uncertainty in a future outcome. Since we are talking about investment, we refer to returns. I told you that we'll be studying two measures. One is the basic measures, which are very standard ones and very simple to understand. And once we get done with the basic measures, we'll go on to the advanced measures, and which is where the maximum amount of maths is. Okay. So we start with the basic measures today. Okay. So the first basic measure is called as standard deviation or variance. Can any help? Can anybody help me define standard deviation here, please?
Standard deviation is the square root of the square root of the square of the square of the deviation from the mean, and square root of the arithmetic mean of the square deviation from the mean.
Okay. Okay. So standard deviation is basically the average deviation from mean. The square root comes because it is the variance. So standard deviation is also called as the square root of variance. Guys, can you tell me why do we, so why can't we directly do x minus mu, summation of x minus mu? Why have to do x minus mu the whole square and then take the root?
That is zero. No, x minus sigma x minus mu is zero. Deviation from the arithmetic mean is zero. No? Sum of the
Correct.
deviation from the arithmetic mean is zero.
Some of the deviations from arithmetic mean will always be zero because the negative and positives cancel each other out. So just to elaborate with a very simple example, let's say 10, 20, 30 is my data. Okay. I know 60 divided by 3. So 20 is my mean. And if I do x minus mu, 10 minus 20 will be minus 10, 20 minus 20 will be 0. This will be plus 10. So it will be always 0. In order to solve this problem, we do the square. So it becomes 100, 0, 100, 200, and then I take the root. Why square, guys? Why can't it be mod? Why can't I did like modulus of x minus mu? So it will be 10.
Modulus, if you take it is minimum that median will come into picture, because it is always a problem like that. Square deviation from the mean, it will be for issue. If you take it from the median, then it is okay.
Okay.
Square deviation from the absolute deviations from the median is minimum. No?
Okay. Anyone else, guys?
So that is the reasons why we take it from the
Square.
mean.
Okay. That's not the exact reason, but let's. Anyone else? Why I did square and then root? I could have also done modulus.
And then we take only positive values, you know.
That too even happens in a square, na Tom? When I square it off, I only take positive values. The purpose of squaring it is just to ensure that negative positive don't cancel each other out.
That will take only upward factor only, the upward deviations only.
That's what happens now. Even here you have positive only. Even in x minus mu, I have converted into everything into positive square when I did. Yeah, Bhavani, go ahead. You are saying something.
So is it because it is differentiable?
Very good. The reason you don't do this because this is very difficult to differentiate. So you don't have a derivative of a mod. The derivative of a mod is a discontinuity. Okay. So in order to ensure that we are able to differentiate and integrate it easily, square ka differential बहुत easy hai. We know that square ka differential is 2x. If I have to integrate, I can integrate it back also. So that is the reason why for standard deviation you don't use mods, you use squares because of the differentiability. Okay. Now we come back to the interpretation, average deviation from the mean, which basically means if I say the standard deviation is 10 and the mean is 5, my values will majorly lie between -5 and 15, which is basically x bar minus the standard deviation and x bar plus the standard deviation. Important word is majorly. Not all values will lie, but majorly my values will lie within the standard deviations that are there. Okay. So standard deviation is also called as, it also gives us the spread of the data or spread of returns. So can I conclude, can I say that higher the standard deviation, more is the risk? Everyone with me, guys?
Yes, correct.
Yeah.
Yes, sir.
Yes, sir.
So can anybody highlight any problems that you see in standard deviation? Why do I have to study other measures? Any problems? It is a measure of risk. We just discussed that higher the standard deviation, more is the risk. Why do I have to study so many measures that I just highlighted at the start last class?
They say if it is all negative, downward risk is there, upward risk is there. No?
Correct. Very
So
good.
that may be the reasons why, because you all negatives, all positives, then some will be, that may be the reasons why.
So the first reason why is what Tom rightly mentioned. Standard deviation is directionless. So when I told you standard deviation is 10, it goes up by 10, down by 10. That's what I did, right? Plus sigma, minus sigma. So it is directionless. It gives you both upside and downside risk. Now, ideally, upside risk is basically profit. From an investor point of view, I'm not too much concerned with the upside risk. Investors want to focus on downside risk only. The second thing, it does not give you a capital value. So the whole aim of the quantification exercise is that you need to know what capital to be set aside in event a risk event happens. Correct? I don't know capital. I max know, okay, this is the standard deviation. Okay. So it doesn't tell, or it doesn't give the capital value or the capital to be set aside to mitigate a loss. Okay. In terms of the formula, guys, I think you guys are very, very comfortable with the formula. Can anyone quickly tell me the formula? One is the discrete version.
Sigma, that sigma is xi minus x squared the whole squared by n, root of sigma xi minus x bar the whole squared by n, standard deviation. No?
So summation of all values of x, which is x bar minus mu. I have not written it x bar. Sorry, x minus x bar. Instead of x bar, I am using mu. So x minus mu the whole square by n. When I take the root of this, I get standard deviation. I'll write the formula for the variance so we are comfortable. So variance of x is equal to this. And when it is continuous, it is integration over the full range. Same thing, x minus mu the whole square dx. Okay. Everyone comfortable? I'll just wait for 2 minutes if you want to copy. No need to copy this. This was just more thought process. Just give it 2 minutes, then we go on to the other measures. Shall I go ahead, guys? Yeah, Riya, Anushka.
Yes, yes.
Yes, sir.
Cool. Okay.
Yes, sir.
Okay. So now, in order to solve one of the problems of standard deviation or variance, we have the second measure, which is called as downside semivariance. Essentially, it is the same as variance only, but it looks at only the variations below the mean. It does not look at the variations above the mean. So if I look at the formula will remain the same, basically x minus mu the whole square by n. But when I sum it, I will sum only for those values of x which are less than the mean. When I integrate it, I will integrate only till mu. Okay. So it is the same as standard deviation. The only difference is I am looking at only the downside risk. Or in other words, the focus is on the downside risk. Okay. Can guys, I have distributions which have the same upside, same downside?
No.
No. Okay. Anyone else?
If the distribution is symmetric, then we have the same upside and downside.
Very good. What does symmetric mean, Riya? Who asked that? Riya or Anushka?
Yes, sir.
Anushka, yeah. What do you mean by symmetric distribution?
Symmetric means that the shape of the distribution is bell-shaped graph, like normal distribution. So we can break it into the two equal parts.
Very good. Symmetric distribution is basically the distribution is same above. Okay, values are same above and below the mean.
Yes, sir.
So you gave an example of one. So if it is a symmetric distribution, the downside semivariance will be simply half of variance. One example that Anushka mentioned is normal. Any other distribution that you guys know is symmetric?
T distribution.
T distribution for values less than 30. So T degree of freedom less than 30. What else? There are others, guys. Think.
Uniform distribution
Very
with the positive the same axis.
The next is the uniform distribution. And the last one I'll say binomial, but binomial with a condition that P is half. The reason I'm making you write all of this is because if it is any of these distributions, it should immediately click you that I don't have to calculate downside semivariance. I will simply take half of variance. Okay. So if it is any of these distributions, which is basically a symmetrical distribution, you need not calculate downside semi-variance. You will simply take half of variance. Okay. Cool. But the problem of capital still remains. Yeah, I'll wait for 2 minutes. You may copy it down. Then I go on to the next measure. Very, very basic stuff, guys. I will do one sum on this, but very, very basic stuff. I'll do the third measure and then do one sum on this. Done? Shall I go ahead?
Yes, sir.
Okay. Now I move on to the third measure, which is called as shortfall probability. As the name suggests, this is the probability of loss below a benchmark level. Again, so in other words, this is nothing but finding probability. Okay, so probability ढूंढना है. We just have to find the probability. If it is discrete, the probability will be probability of x less than L will be nothing but summation of P of x equal to x for all values of x less than L. If it is continuous, it will be probability of x less than L instead of summation, it will be integration. So minus infinity to L f of x dx. Okay, so this tells us that, let's say if I don't want the loss to exceed 10 lakhs. Okay, so I'll say what's the probability of loss exceeding 10 lakhs or my return taking a value below 10 lakhs. Okay, I'll get the probability, and if the probability is high, I would decide whether or not to invest in the project. Okay, again, this solves somewhat the capital problem, because you will say that 10 lakhs needs to be kept aside, and if the loss is more than 10 lakhs, if there is a very large possibility of loss more than 10 lakhs, you will not invest. Okay, but still it is not very comfortable because it does not tell you the loss limit or the extent of loss. So extent of loss not known, hence deciding the capital may be difficult. Okay, so these three guys were the basic measures. Typically, if I talk about an exam question, you will have 2 marks max of this. So you will be given a distribution or a case, and you will be told to find all three. Okay, so it will be 2 marks, max 3 marks of weightage, or max 4 marks of weightage, depending upon the difficulty of the sum. Let me know when done. We will do 1 or 2 sums which are a little exam style on this, calculating first 3. Shall I go ahead? Okay. Let's look at a sum. Okay. So I've been given a variable R, which is basically equal to 250 minus 1 lakh n, where n is given as the normal distribution. I have to find for R variance, downside semi-variance, and shortfall below benchmark level of 50,000. Yes. So let me ask one person at a time. Priya, help me solve the first variance.
Yes, sir. So we'll take the equation of R.
Very good. So variance of R, in which I will variance of R, I will just substitute the value of R, which is 2,50,000 minus 1 lakh n. After that,
We can break it using the operator.
okay, go ahead. What will happen? So variance of 2,50,000 will be
A variance of 2,50,000 will be
what happens to a variance of a constant, Riya?
0.
Very good. It will be 0. 2,50,000 is a constant. It doesn't have any variation. So variance of 2,50,000 will be 0.
And 1 lakh will come out as square and variance of n minus.
Minus 1 lakh square. So 1 lakh will square will become positive. So 1
Yes.
lakh square. Variance of n. What will be variance of n, Riya?
1. It's
Very
given.
good. It's a normal distribution. So variance of n will be 1. Cool. Bhavani, what will be the downside semi-variance?
Sir, half of variance.
Very good. Why?
Because it is a symmetric distribution.
Excellent. So it will be half of variance since normal. So half into 1 lakh square. Kaustubh, third one. Probability of loss, probability of R taking a value less than 50,000. Kaustubh?
Yes, sir.
Yeah. How will I go about it?
Which one, sir?
Probability of R being less than 50,000. The third one, shortfall probability.
Sir, I'm not able to formulate that.
So what you do is same thing. Instead of R, substitute the values of R. What was R? 2,50,000 minus 1 lakh N. So 2,50,000 minus 1 lakh N less than 50. 2,50,000 goes there, so it will become minus. So it will be minus of 1 lakh N minus 2 lakh. This can cancel off. So when I cancel this off, I have to change my signs because I'm multiplying by minus 1. Okay. Then N goes and divides. Sorry, this goes divides here. So N greater than 2. Now N is a normal distribution. What do you do in case of a normal distribution, Kaustubh? If it's a normal, how do you solve for probabilities? With me till here, Kaustubh?
Yes.
Yeah, so you convert it into standard normal. How do you convert? You say X minus mu by sigma. So P will be Z greater than 2 minus mu. Mu for us is 1, sigma for us is 1. So 2 minus 1 upon 1. So this will be Z greater than 1. Everyone knows how to look at the tables, right? You know how to look at the tables, normal tables, Kaustubh?
Yes, sir.
Yes.
Yeah, you just look at the table. This is a greater than case. So you will not find this in the table. You have to do 1 P less than 1 and you'll get your answer. Cool. Copy it down, then I go ahead. I'll do one more, I think. Let me know when done. We'll do one more. Done, everyone? Shall I go ahead? Yeah, done?
Yes, sir.
Okay. So let's do one more. Now R is equal to 3 lakh minus 5 lakh U. where U is a uniform 0-1 distribution. Calculate variance, downside semivariance, and shortfall at 50,000. This you will do it on your own. I will give you 5 minutes. Okay, or let's take 10 minutes. It's 8:17, 8:27. Try it out on your own and then I will solve it with you. Yeah, 10 minutes and you have to get it done. Huh? Everyone on track, right?
Yes.
Okay.
Yes, sir.
Cool. Let's begin. Bhavani, if you could help me with variance.
Yes, sir.
Yeah. Yeah. How will I solve for variance?
Variance of 3 lakh minus 5 lakh U.
Variance of 3 lakh minus 5 lakh U. Fair enough.
That will be equal to 5 lakh square into variance of U.
Very good. What will be variance of U?
That would be 1 minus 0 whole square by 12. That is 1
Very
by
good. So uniform, the formula is b square minus a square by 12. So 5
b,
lakh.
b minus a the whole square by 12. And
My bad. 5 lakh square. B for us is 1 minus 0 whole square, which is 1 square by 12. So 5 lakh square by 12. Kaustubh, the second one, downside semivariance.
Sir, 5 lakh square by 24, which
Very,
is 1 by 2 into variance.
very good, since symmetrical. Ria, shortfall, probability that U is less than 50,000.
Yes, sir. Probability 3 lakh minus 5 lakh U less than 50,000. Then probability minus 5 lakh U less than minus 2 lakh 50,000.
Okay.
So it will be u greater than 0.5.
Very good.
So it will be 1 minus probability u less than 0.5 and 1 minus probability u less than 0.5 will be x minus a by b minus a.
So x for us is 0.5.
5
A
minus
for
0,
us is 0. B minus A
1 minus
is 0.5. So the probability is 0.5.
0.5.
So it can be another way also, no? If we take that u is equal to 0, 1, if we take r, it will be this r will be less than 50,000. No, it will be 0. The range will be different. No, if we take 0 and 1, so we'll get a different answer.
That's what we did now. 0 and 1 only, na?
So if we take that we take the transformation u is equal to 0 and 1. So if we take that, it will be r will be less than 50,000. No?
That's what we did now. R is less than 50,000. That's what we started.
So the range is.
So if you substitute, so let's say what Tom's saying. Correct me if I'm wrong, Tom. So let's say what I can say is I will substitute u equal to 0, in which case r will take a value of 3 lakh and if I substitute u equal to 1, r will take a value of minus 2 lakh.
Yeah.
In which case also answer should not be different, Tom.
Yeah, correct.
Yeah, so the range will be 3 lakh to minus 2 lakh.
Yes.
Or minus 2 lakh to 3 lakh.
Yes. So it will be r will be less than 50,000. So it will be correct. So both ways.
Both ways answer will be the same. You can do both ways.
Yes. Got it.
Yeah.
I tried both ways. That's right.
Okay. Cool, that's good. Let's move on to the advanced measure. The first advanced measure that we are going to do is VAR. I will just introduce VAR today. It stands for value at risk. Okay. It is always abbreviated as VAR. Okay, the R is capital, A is small. Now what is VAR? Okay. Now for us to understand VAR has three things. One is VAR is a loss level or a loss amount. It is a loss level with a given probability. And it is over a period of time. So whenever I look at a VAR definition, these all three terms will always be there. Okay. There are two ways to define VAR. First, it is VAR is the loss, okay, amount which will not be exceeded with a given level of confidence over a period of time. Example, loss will not exceed 10 lakhs 95% of the time over 1 year. So I see all the three elements, the amount of loss, the level of probability or confidence, and the time horizon. Okay. Now the same thing can also be stated in a different way. Okay, the same thing can be stated in a different way. Loss will exceed, okay, a specified amount with a given level of significance. If you remember confidence intervals, guys, level of significance is alpha. Level of confidence is 1 minus alpha. Okay, the same things go ahead. Exceed with a given level of significance over a period of time. So if the same thing has to be said here, I will say loss will exceed 1 lakh, or sorry, 10 lakhs 5% of the time over 1 year. Everyone clear, guys, with both the definitions? So whenever confidence levels are used, you will say loss will not exceed. Whenever levels of significance are used, you will use loss will exceed. Everyone clear, guys?
Yes, sir.
Yes, sir.
Cool. Okay. So now how do you find it mathematically? Mathematically, if you have to find var, so let's say probability of x less than t will be equal to alpha. Now typically, guys, alpha will be given in the question. The distribution of x will be given in the question. We have to find t. So guys, this is the exact opposite of shortfall probability. Shortfall probability में loss दिया था, probability ढूंढना था. Loss was given, we had to find probability. In this, it is opposite. Probability is given, we are finding loss. Okay, and we will say that var of x will be whatever is negative of t. Why do we do it like this? Because var is a loss level. Okay, so if t is negative, var will be positive. So, and if t is positive, var will be negative. Okay, so if var is positive, it basically means a loss. var is negative, it basically means a profit. The laws are different for var. Why? Because var is a loss level. Everyone clear, guys?
Sir, I lost my connection with this mathematically.
Mathematically, if you have to find, I will basically do x less than t is equal to alpha. You will be given the probability, you have to find the loss. So मतलब ये shortfall probability का उल्टा हो गया. Shortfall probability में हम लोग को benchmark दिया था. Benchmark was given, we were finding probability. In this, we are given a probability and we are finding the benchmark. The t is the benchmark. And I will say that var of x will be equal to negative of t.
Yes, sir. Got it.
Cool. Okay. Shall I go ahead, guys? Cool.
Yes, sir.
Now, when I talk about sums, I will bifurcate the sums into two types, guys. One is discrete and one is continuous distributions. Now, if it is continuous distributions, it's simply formula approach. First, I will say probability of x less than t is equal to alpha. I will solve for t. Okay. Then I will say var of x is equal to negative t. Okay, and I'll state my var. So for continuous, it is purely formula based. If it is discrete, the important thing to note here, this will be observation. There is no such formula for discrete. Okay, I can solve the sum two ways depending upon the definition of var that I follow. So if it is a level of confidence wala definition, then I will plot returns given in a descending order and then take the cumulative probability. The probability interval where 1 minus alpha lies is my var. If I use the level of significance approach, I will plot the returns given in an ascending order. And then take cumulative probability. The probability interval where alpha lies is my var. Am I clear, guys?
Yes, sir.
Cool. Copy this down. I will do the continuous one today. And what time is your test, guys? 9:15, right?
Yes.
Yes,
Then
sir.
I think I'll do the sums tomorrow then. That's fine. I'll give you 15-20 minutes more off so that you guys can just get in the right state of mind. I'll end it today. I'll do the sums from tomorrow. I'll complete ये दोनों के sums. 2 sums of continuous, 2 sums of discrete. And then we go ahead. Let me know when this is done.